Test-driven development consists of building the application logic bit by bit, following a repeating cycle of activities. People like to call it the red-green refactor cycle. In case there are any Canadians watching this, I'll just mention the name has nothing to do with the red-green show to avoid confusion. Okay, the first step, red, involves making an assertion about the behavior of the code. The assertion will fail because the production code doesn't yet support the desired behavior. The reason it's called red is that most development tools display failing test cases in red. Eclipse does too, and you'll see that in a moment. To begin, we work out enough of an upfront design so that everyone is on the same page about how to start. We don't develop a detailed upfront design. We do just enough to get started. That's okay because we intend to get feedback about how development is progressing at frequent intervals. Let's say our upfront design says the first thing we want to see is the phrase "Hello World." We'll have a method we can call to tell the application to greet us. One of the tenets of TDD is not to try and write a large amount of code all at once without validating it. We'll test drive just that tiny bit of functionality and nothing more. So here we go. In the Package Explorer pane, we see our two source folders. Let's right-click on the test folder so that we can open the context menu. And this time we choose New, followed by JUnit Test Case. This opens a dialog window where we can define a few details about the test case we want to write. We want new JUnit 4 test, so we make sure that radio button is selected, and it is. JUnit 3 is supported for backward compatibility with legacy code. It isn't used for new development. The test source folder is shown, and that's the one we want, so that's good. The default package name hello probably isn't a very good name. Let's create a package named com.leadingagile.greetings. This name field is for the name of the class, so this will be a valid Java class name. By convention, test class names either begin or end with the text test. I'm going to name this one Hello Test. We don't need to create any of the method stubs it's offering us, and we don't need to worry about generating comments for purposes of this exercise, so we'll skip those. The class under test field pertains to after-the-fact testing, and that's not what we're doing, so we can leave it blank. Everything looks good so far, so let's press Finish. Well, now Eclipse tells us the JUnit 4 is not on the build path. This happens the very first time you try to use JUnit with Eclipse. It will add the library to the path if we ask it to. The default action is to add the library, so we just press OK and go on. Eclipse opens the new class in the editor pane, and we see it listed in the Package Explorer pane under the new package we created. Eclipse generates a little bit of helpful boilerplate code for us. It adds an import statement for the JUnit assertion library, and it includes a default test method we can use as an example. That's right here. So let's mention a few clean code points that this class raises. First, we have an import with a star. Most Java developers would prefer that we import just the specific items we need, but we'll leave that as it is for now. This is a static import, and a rule of thumb for Java is to avoid static imports because they tend to make it non-obvious where dependencies are coming from. This can be a problem for larger, complicated classes that use several libraries. In the context of unit test code, we usually allow static imports because otherwise the test code would be cluttered with fully qualified references to components of test frameworks, mocking libraries, and custom matcher libraries. There isn't any mystery about where these dependencies come from, so it's more valuable to minimize visual clutter than to avoid static imports, at least for the test code. Let's take a look at the test method. It has the annotation test. This tells JUnit4 that the method should be executed when we run our unit tests. This signature public void is required for a test method using JUnit4. So the default implementation calls a method fail, which will cause the test to fail. This is useful because JUnit's default behavior is to pass a test case that has no assertions. An empty method, or a method in which we forgot to code an assertion, would appear as a false positive. So it's good that the default boilerplate code fails the test case. Now let's get down to the serious business of saying hello. We'll modify the default test case to meet our needs. We want to call a method greet on an object of type hello, and we want to assert the result will be the string hello world. First, I'm going to change the name of the method to be more descriptive. Let's call it says hello world. I think that's a little more descriptive than test. Now I'm going to instantiate an object of type hello. This will be the subject of the test. Okay. Now at this point, Eclipse complains because there's no such class as hello. We can use the IDE to help us create one. If we hover over the red line, Eclipse will display some options for us. There we go. It says the problem is hello cannot be resolved to a type, and it offers us 7 quick fixes that it can do automatically. Let's choose the option to create the class. We want the class hello. Okay. This opens a dialog window where we can provide details about the class we're creating. The first thing we need to do is change the source folder. We want the production hello class to live in the production source folder. So I'm changing test to main here. Okay. I'll leave the rest of the defaults unchanged and press finish. Eclipse creates the class, opens it in the editor pane, and puts focus on it. So going back to hello test, we see compiler errors are gone, and there's now a warning, and that's because we aren't referencing this variable anywhere. But that's okay, that's just where we should be at this point. So how will we tell the hello object to greet us? Maybe something like this. Okay, that could be a way to tell it to greet us. Great. Now Eclipse complains because there's no method greet on the hello class. So we can use the IDE to help us out again. You see that one of the options it gives us is create method greet in type hello. Okay, so we'll do that. Eclipse puts us back in the editor pane looking at the hello class. It added the method with the appropriate signature. I'm just going to get rid of this boilerplate comment that it generates. That's not very helpful. Okay. And we'll save the file. Now I want to assert, back in the test, I want to assert that the result of the call will be the string hello world. So we can add an assertion to that, to the test case. Assert equals, and with JUnit4, the first argument to assert equals is the expected value. We expect hello world to be returned from the greet method. So we'll just specify that variable as the actual. So we have the expected hello world, and the actual is the value of a greeting. And we can get rid of this fail line. We're not going to do that anymore. And it looks like everything is compiling. So we're ready to try to run this. We'll just select the test method name and right-click to get the context menu. This time we're going to look for Run As JUnit Test. So here goes. Okay. Eclipse displays a red bar. This means at least one test case failed out of the massive number of test cases we just ran. It shows a list of all the test cases that were executed, and there's an icon next to each one that indicates whether it passed or failed or just couldn't run for some reason. So this is showing us the single test case failed. Okay, and down here we can see the reason for the failure. We expected to see hello world. The actual result was null. And that's correct at this stage. We have red for the right reason. And that's the first step in the red-green refactor cycle. So we're on our way. The next step in the TDD cycle is to make the test case pass, make it green. That means we add just enough logic to the production code to make the application behave the way the test case expects it to behave. Let's do that now. Eclipse will help us find the appropriate line. If we click on it, double-click on it, it takes us straight to the hello class in the editor and straight to the assertion that failed. We can see the real cause here is that this greet method is returning null. So let's just make it return what we want. We won't try to be fancy. Just the simplest thing that could make the test case pass. And that compiles. So let's try the test case again. Eclipse gives us a shortcut to rerun the last thing we ran. We can click this icon on the toolbar that looks like a play button on an audio player. So let's do that. This time it's green. We're getting the behavior that we want, so that's good. We've just completed the second step in the TDD cycle. It means the production code behaves in accordance with our expectations. It does not magically mean the production code is correct for all possible definitions of correct. It just means it does what we think it should do right now. We're doing a fair amount of clicking. There are keyboard shortcuts for just about everything we're doing, but I don't want to get bogged down with that in this exercise. The shortcuts vary by editor and IDE, and they vary based on whether you're running on Windows, OS X, or Linux, or maybe using a Linux VM with an OS X host and a Mac keyboard, and all that. You can remap the shortcuts too. Let's not go there just now. Ultimately, you'll want to learn the keyboard shortcuts for the tools you are using because it speeds things up considerably. Now that we're green, we can proceed to the third step in the cycle, refactor. Refactoring means changing the underlying implementation of the code without changing its outwardly visible behavior. This brings us to one of the key benefits of TDD. The test cases serve as a safety net for refactoring. People often claim TDD helps control the accumulation of technical debt over time. This is the mechanism by which it does so. Thanks to the test suite, refactoring becomes safe, easy, cheap, fast, and low risk. We can keep the code base clean incrementally in the course of making enhancements and fixes to the application throughout its lifetime. If we want to be sure we haven't inadvertently changed behavior, we start with green tests, refactor, and then run exactly the same tests again without any modification. They should still be green. So let's take a look at the code we have so far and see if there are any opportunities for simplification or other improvements. Looking at the test code, there doesn't seem to be any need for this intermediate variable greeting. We could consolidate the call to greet with the assert equals call. Let's do that. I'll just copy and paste it. Just don't tell anyone I did copy and paste. And we can delete that line. Okay, that takes us from 3 lines to 2. It's a little easier to follow what's going on in the test case. Remember, they won't always be this simple, and there will usually be hundreds or even thousands of them. Even a small simplification goes a long way. Let's run the test case again to be sure we didn't inadvertently break something. Let's get the context menu and do run as JUnit test. Okay, we didn't break anything. It might seem kind of obvious in this case, but it's a good habit to run the test frequently because it helps us notice simple things we might tend to overlook. Okay, good, we're still green. Now what about that string literal? Hello world. A general rule of thumb is to avoid string literals in our code. In the context of unit test code, there's a slightly different philosophy. Each test case is a concrete example, and there won't be many, if any, reuses of the same literal values. For the test code, it's better to leave the literal in the test case rather than forcing people to scroll through the code to find the definition of a constant. It's the opposite rule of thumb from production code. Another reason to leave the constants in the test code is that the production constant might be defined wrong. If we depend on it for both the production and test code, we'll get a false positive. So we'll leave the string literal in place. Now let's look at the production class and see if we can refactor that. Well, there isn't much here, but there's that string literal again. This time we're looking at production code, so we probably want to get the literal out of the method. Let's use a built-in refactoring that Eclipse provides. Other IDEs provide similar features too. I'm going to highlight the literal text, including the quotation marks, and then I'm going to right-click to open the context menu. This time I'm looking for refactor, and under the refactor submenu, there are several options. We want to change this literal into a constant, so we'll choose extract constant. And it is right there. Okay. This opens a dialog window where we can enter details about the refactoring we want to perform. Eclipse creates a name for the constant that is just the string value converted into a conventional Java-style constant name. In this case, I'll suggest we change the name to something more meaningful in the context of the application. How about this? Okay, I didn't hear you say no, so I'll assume you're okay with this name. You can choose the access modifier too. Private is appropriate in this case. Yes, we do want to replace all occurrences, although we know in this case there's only one, but normally we would do that. There's no need to add a qualifier to the name. So this shows us what we've defined in case we want to change our minds. And that looks okay. So I'm going to choose OK here. And we see Eclipse made the changes for us. Created the constant definition and substituted the constant name in the code. Okay. Now let's run the test case again, just to be sure we haven't broken anything. Never hurts, and it's cheap. Okay, we're still green. So you may have noticed we run the same test case over and over again many times. Every time we make even the smallest change, we check to be sure we haven't broken anything. That's part of the TDD workflow. Running these unit tests is very cheap and very fast, so why not take advantage of them? Okay, we're still green before and after the refactor. We just completed one TDD cycle. Before we go on with more features, let's commit our changes to version control. You might be used to waiting until you've completed a fair amount of work before committing changes. That's the norm with traditional development methods. With a TDD workflow, we want to check in very small changes very frequently. This gives us the flexibility to recover from mistakes quickly, cheaply, and easily. It also avoids merge hell, as collisions are rare, and when they do occur, they're of small scope. We'll use Eclipse's support for Git. Let's go to the Package Explorer pane, and we'll highlight the project name by clicking on it once. Now we right-click to open the context menu. Scrolling down to Team, we choose the first option in the submenu, Commit. This opens a tab in the lower right-hand area of the Eclipse window. I want to see more of that, so I'll double-click on the title of the tab. That expands that tab to fill the Eclipse window. There's a two-step process to commit with Git. First, we tell Git which files we want to be included in the next commit. In this case, we want to commit hello.java and hello-test.java, but not the other files listed here. So we'll highlight these. I'm just clicking on them and holding the Shift key down, clicking again. And now we'll right-click to open a context menu. That seems to happen a lot. And we choose Add to Index. This is the same as the git add command on the command line. It stages the selected files for the next commit. And now you see those two files in the Staged Changes section of the Git Staging panel. Now we need to add a commit message. Let's just call this Basic Hello World Implementation. Okay, now we can press Commit in the lower right-hand corner. This is the same as the git commit command on the command line. And that's it. The two files have disappeared from the Git staging pane as there are no changes compared with the current branch. We can double-click the tab to restore it to its original size, and then we can dismiss it by clicking this X. Okay, full disclosure, I cheated a little in the interest of time. In real life, I would have committed to the local repository when I reached green and before refactoring. That gives me an additional safety net in case I need to revert. Then I would commit again after refactoring and push the changes. Now we'll move on to the next requirement. Our customer wants the system to greet people by name, so we'll add the option to pass a name into the greet method. We expect the application to insert the name into the greeting message. So if we pass in Fred, we want to see Hello Fred instead of Hello World. A novice impulse is to add the new assertion in the same test method, the one we already have, like this. Seems to make sense to do that. It's very similar code. Instead, though, we want each distinct fine-grained piece of behavior to be asserted in a separate test case. For Java, that means a single test case exercises exactly one logical path through one method. If there is conditional logic in a method, it calls for multiple test cases. These are very small unit tests. That's why some people prefer to call them microtests. That name helps distinguish this style of unit tests from tests of larger scope that may be valid for other purposes and that might still be referred to as unit tests. Well, let's start then by creating a second test method. Well, let's cut this line, as this is going to be useful in a minute, and we'll create a new test method. Let's call it says Hello Fred. And we're going to need a hello object to test against. And then we can paste in this line that we rescued from the previous attempt. Okay, and of course Eclipse complains because there's no method greet on class hello that takes an argument. So it offers us some options. We can remove the string argument from our call here, but we don't really want to do that because then we wouldn't have a way to pass a name in. So that's not so useful in our case. We could add a parameter to the existing greet method, but then we would have to pass null or some other special value to indicate the default case when we want to see hello world. Well, we don't want to do that because conditional logic based on a null argument isn't considered good practice. The third option, we can create a new greet method that takes a string argument. And that seems sensible, so let's choose that option. And Eclipse takes us to the hello class and our new method. Okay? And it does a pretty good job of guessing what we want, but we'd like to have a string as a return value, so let's fix that. And the name string isn't very descriptive. Let's change that to something that makes more sense in the application's domain language. We're passing a person's name, so we'll just call this name. As usual, I want to remove the generated comment there. So now we have a method that has a default behavior, and the compiler seems to be happy now. Okay, so we've made the compiler happy, so let's run our new test case the same way we did before. We will get the correct context menu here, or we won't. There it is. Run as JUnit test. And we have a failure. Is it failing for the right reason? Well, we expected hello Fred. The result was null. That is the right reason. So we have reached red for our second test case. To make this test case pass, we need to add some logic to the greet method that takes an argument. Let's switch over to the hello.java file in the editor. And here's the method. In keeping with the TDD approach, we're going to write just the minimum code necessary to get the behavior we're looking for, even if it's not the cleanest possible implementation. So here goes. Okay. It might seem counterintuitive to write such a crude implementation, but there's a purpose in doing it this way. We want to avoid wasting time polishing code that we might discard in the course of evolving the low-level design. We write a bare-bones implementation and make sure the functionality is correct before we invest time and effort in refactoring. In the long run, this actually saves time compared with trying to perfect the initial version of the code. Okay, then let's run the test and see if it passes. And it does. Okay, so we've reached green in our second TDD cycle. Running all the tests, we see that we're green across the board. That's good. I'm going to take a moment to commit what we have so far, so we'll have a baseline of working code in case we need to revert. Just like last time, I'll select these source files, stage them, and provide a commit message. Okay, good enough for now. And let's put that down in the corner again. Now let's look for opportunities to simplify. First, let's look at the test code. I see duplication. The hello object is instantiated separately in each test method. We need the same setup for both test cases. To avoid this kind of redundant code, unit testing frameworks can run common setup code prior to invoking each individual test case. Using JUnit, we identify these methods with the annotation before. Let's pull the new calls out of the individual test methods and consolidate them in a before method. Our goal is to make hello an instance variable and to create a before method that instantiates a hello object prior to each test case. To do that, we're going to do 2 refactorings as well as some manual work. Sometimes a refactoring involves more than just a right click. First, we'll convert the local variable hello to an instance variable. Java calls instance variables fields, so that's the terminology we'll see in the refactoring menu. I'm selecting the local variable hello, by clicking on it once, and that sets the context for the context menu. So I'm going to right click to open the context menu. Now I'll choose refactor and convert local variable to field is the one we want. So I'll choose that. In the convert local variable to field dialog, it shows the name will be hello. I think that's okay. And down here under initialize in, the default is to initialize the variable in the current method. We are going to instantiate the variable in a different method that doesn't exist yet. So let's change that setting to field declaration. Okay, now we don't want it to be static, so the default setting is good. Now we can press OK and go on. And here we have our shiny new instance variable. That's good, but that's only half of what we want to accomplish. So let's turn to the refactoring menu again to extract a method. This time I'm highlighting all the lines I want to be in the new method. In this case, it's just this one line. So we'll open the context menu again and look for refactor and extract method. And there is that dialog box. Now look at the message signature previewed here. This is a method that returns a value. The before method is going to be void. We don't have that option here, but this is pretty close. So let's go with this. We'll give the method a meaningful name. I suggest we call it before each. Suggest what it does. It's going to run before each test case. Okay, so let's hit OK. And there's the new method down at the bottom there. JUnit requires a signature of public void, so we need to change the return type to void. Okay. And I'm going to remove the return statement. And we don't want to instantiate a local variable here. We want it to instantiate the instance variable, so I'll just remove that part of the declaration. Whoa. And one more thing to do. To tell JUnit what this is, we need to add the annotation before. And we have to tell Eclipse to import that. And it doesn't make sense for the before method to be way down here. Usually people expect these to be at the top before the test cases. So I'm just going to cut and paste it up to the top. And finally, we need to remove this line from this method. The first refactoring removed it from the first method, but not the second one. Okay. So this looks pretty good so far. So the compiler is happy again. Let's run the test, make sure we didn't break anything. And it looks good. Good. So time for another commit. This probably seemed a bit clunky and long, but that's because refactorings sometimes require multiple steps and sometimes require some manual work. It's not always just a click and go. But it's still useful to let the tools do some of the work for you, because then you can't accidentally miskey something. So that's a good idea to do. Obviously, I can't think of a commit message while talking, but that's not a problem with TDD. What else could be improved in the Hello Test class? I see an opportunity to make the method names more expressive. The method name, it says hello world, was pretty descriptive back when we had just the one test case, but now this naming pattern is becoming less meaningful. I'm going to change the names. I'm going to suggest we say, it says hello world when no name is passed in. I think that's a little more descriptive. Okay. Okay, let me just run the test cases again. Okay, still good. So why not wait until I've changed the other method name before running the test cases? Well, the real question is, why wait? The unit tests are fast and cheap and provide immediate feedback if we make a mistake. It's helpful to run them frequently, and that's the habit that I'm in. I run them over and over. Now you might ask, well, what's with the weird method name? It's long and it has an underscore in it. That doesn't look like a conventional Java method name. Well, here's the thing. Method names in test classes are a little different from method names in production classes. We want the method name to express the intent of the test case. A multitude of these methods will serve in effect as the technical documentation of the system. New team members need to be able to read them quickly and get an accurate sense of what's going on. Test method names tend to be much longer than production method names, and different parts of the name may be separated with underscores, so they are more obvious to people reading the code. Often a test method name will indicate something about the preconditions, postconditions, and purpose of the test case. The name, it says hello world when no name is passed in, expresses the postcondition, it says hello world, and the precondition, no name is passed in. So let's do the same thing with the other test method name. It says hello Fred when Fred is passed in. Okay, we'll run the test again. So far, so good. The hello test class is looking pretty good now. Let's take a look at the hello class. Okay, a couple of issues stand out. First, our implementation of this method greet with a string is pretty sloppy. A more idiomatic way to insert values into a string in Java is to use the message format class. So let's change that implementation. We want to do a format, and the IDE is helping us here by suggesting things that we might want to do, this auto completion. Format is the method we want, so let's go ahead and choose that. And it's telling us the first argument is the pattern. So let's give it the pattern we want. Hello, comma, space, a placeholder for the name, and an exclamation point. And close that quote. We'll tab to the next argument, and this is an array of values that will be substituted into the various placeholders. So let's make an array with one member, and it's the name. And we can erase this old code. Okay, the compiler seems pretty happy with that, so let's run the test. And green, so before and after the refactoring, the tests were green. So that's good. So what else might we do here? Well, there's a string literal now. This pattern is a string literal. Well, let's extract that. Let's make that into a constant. We'll go to refactor, extract constant. And it gives us a default name of hello 0 I'm not too happy with that name. Let's make that more descriptive. This is actually the pattern for all the greetings that we might generate, so we'll call it greeting pattern. And we want to replace all occurrences. It can be a private member variable, private constant. Okay, let's hit OK. And it generated it, and it replaced the occurrence. So that's good. So let's run the tests again. Okay, we're still good. We haven't broken it yet. I have a feeling this bit could be a little simpler. I suspect the compiler will know what we mean if we just type name and we don't worry about creating an array here. Let's give that a try. Oh, forgot to save. That's okay. Okay, yeah, that worked. And it was easy to learn that because having the safety net of the unit test makes it possible to try things with very little risk. What else can be simplified here? I think I see duplication. Do you see it? Actually, it's not exact duplication, it's near duplication. We have these two constant values that are nearly the same. And we have these two methods that are nearly the same too. So let's see if we can simplify that. Near duplication is a very common situation in a lot of legacy code. It even happens in legacy code that we just wrote a minute ago. So it's good to cultivate an eye for it. I think a single method can handle both these cases. The word world can be handled just like a person's name. Let's change the constant name default message to default name. I click once, double click to open the context menu. I choose refactor and rename. This lets me type in a new name, and it makes sure that all occurrences will change. And then I press enter when I'm done, and we have changed it. Now let's run all the tests and make sure that much worked. Okay, so far so good. Next, we want to change the value of default name to world instead of hello world. We don't need to refactor to do it. There's only one occurrence of this string literal, so I'll just edit it manually. Don't need the exclamation point. Now if we run the tests, we expect to see a failure because world is not equal to hello world. There should be just the one failure and all other tests should still be green. Let's try it. Okay, we got what we were expecting. The failure was we were expecting hello world and we got world. The other test still passes. So this tells us we are where we want to be right now. The next thing to do is to have the noArgument greet method call the second greet method passing world as the name. So let's do that. Okay. Now let's run all the tests and see if we did what we needed to do. It looks like we did. Okay, good. So we have simplified this a bit, and I like simple things. So we're finished implementing the second requirement. Time to commit again. Let's just pretend we did in the interest of time. Our customer may want to be able to say hello in many more ways, but it may be important for their business to ship something that works rather than making people wait for the rest of the features. Because we used TDD as our development approach, we have working code that supports at least some functionality. If it makes sense to ship now, we can do so and then continue with further development. That isn't possible using traditional methods with long lead times and big bang delivery. We can continue in the same way to build applications of arbitrary size and complexity. By refactoring incrementally, we ensure the design never accumulates much technical debt, and the difficulty of understanding and modifying the code remains more or less the same throughout its production lifetime. To earn that benefit, we must remember to take the TDD approach when making enhancements and when fixing production bugs as well. That's TDD in Java in a nutshell. There are more nuances to the subject, but you've got the basic mechanics now. Have fun with it.